Two travelers are considered to be current carrying conductors for derating according to NEC 310.16b4. This means when you have a three-way switch circuit, the two wires that act as travelers between the two three-way switches need to be accounted for when calculating the ampacity of the conductors within a conduit or cable. The National Electrical Code, or NEC, provides guidelines for derating conductors to ensure electrical safety and prevent overheating, which can lead to insulation damage or even fire hazards. Derating is the process of reducing the allowable ampacity of conductors based on factors such as the number of current-carrying conductors at a raceway, conduit, or cable, as well as the ambient temperature. NEC 310.16 is a crucial table that provides the allowable ampacities of insulated conductors rated up to 600 volts based on their size, insulation type, and temperature rating. It is imperative to use the correct column that correlates to the temperature rating of the conductor insulation. NEC 310.16b4 specifically addresses the adjustment factors for more than 3 current-carrying conductors in a raceway or cable. When the number of current-carrying conductors exceeds 3, the allowable ampacity of each conductor must be reduced by a certain percentage as specified in the table. This adjustment is necessary because the heat generated by multiple conductors in close proximity can raise the overall temperature within the raceway, potentially exceeding the conductor's insulation temperature rating. In a three-way switch circuit, two switches control a single lighting fixture or other electrical load from two different locations. The circuit utilizes two traveler wires to allow either switch to turn the load on or off, regardless of the position of the other switch. Since these traveler wires carry current during normal operation of the circuit, they are considered current-carrying conductors. The neutral conductor in the standard 120-volt circuit is only considered a current-carrying conductor if it carries significant harmonic current, which is generally not the case in residential lighting circuits. Therefore, in a three-way switch circuit within a conduit, you must consider the two traveler conductors plus the other current-carrying conductors, such as the ungrounded hot conductor supplying the first three-way switch and the switched hot conductor going to the lighting load. For example, consider a scenario where a conduit contains an ungrounded conductor, a neutral conductor, a switched conductor, and the two traveler conductors for a three-way switch circuit, totally 5 conductors. If all conductors are current carrying, according to NEC 310.16b4, you would need to apply a derating factor based on the number of current carrying conductors. The derating factor will reduce the allowable ampacity of each conductor, and this derated ampacity must be equal to or greater than the overcurrent protection for the circuit. If the initial ampacity of the conductor after derating is less than the breaker size, then the wire size needs to be increased. To determine the appropriate derating factor, refer to NEC 310.16b4. This section provides adjustment factors based on the number of current-carrying conductors in the raceway. For example, if there are 4 to 6 current-carrying conductors, the allowable ampacity must be reduced to 80% of its value as specified in NEC 310.16. For 7 to 9 conductors, the ampacity must be reduced to 70%, and so on. It is important to note that equipment grounding conductors and bonding conductors are generally not considered current-carrying conductors for derating purposes, as they only carry current during fault conditions. However, if the neutral conductor carries a substantial amount of harmonic current, it may need to be considered a current-carrying conductor for derating purposes. This is more typical in commercial and industrial settings with nonlinear loads. Proper conductor derating is essential for ensuring electrical safety and preventing overheating. Always consult the latest edition of the National Electrical Code and follow the manufacturer's instructions for all electrical equipment and materials. Remember to consider all relevant factors such as the number of current-carrying conductors, ambient temperature, and conductor insulation type when determining the appropriate conductor size and derating factors for your electrical installation. Neglecting to account for the traveler wires in a three-way switch circuit as current-carrying conductors can lead to undersized conductors, which can overheat and potentially cause a fire hazard. Always err on the side of caution and consult with a qualified electrician if you have any doubts or concerns about conductor derating or any other electrical installation requirements. In summary, When dealing with a three-way switch circuit, the two traveler wires are considered current-carrying conductors for derating purposes according to NEC 310.16b4. Be sure to include these conductors when calculating the total number of current-carrying conductors in a raceway or cable, and apply the appropriate derating factors to ensure the safety and reliability of your electrical installation. Always follow the National Electrical Code and consult with a qualified electrician when necessary. By properly derating conductors, you can help prevent overheating and ensure the safety and longevity of your electrical system.